acid must have a carbon, double bond O, and another O, and a carbon. Then you can choose, are you going to add more carbons to the right, or are you going to add more carbons to the left? Okay, when I say you choose, it's not always your choice. It depends what structure they want. In this instance, we could have chosen. So we chose in the first one to add the third carbon to the left, and the other one we added to the right. Okay. Then when we looked here, we said this thing with the double bond C is considered the parent chain, the main chain. And this thing that is after the O or attached to the O, that is considered the side chain. So the one with the double bond O is always the parent chain. The one with the O and then a carbon is always a side chain. So one carbon on a side chain is called methyl. Two carbons are called eth. And then the suffix for an ester is O8. So it's ethan O8. Okay, so methyl ethan O8. And then I also said this thing here, the parent chain, where it comes from is the carboxylic acid. So this carboxylic acid would have been ethanoic acid. And the side chain always comes from the alcohol. So this would have been a methanol. Okay, so these two together gives you methyl ethanoate. We're going to get to a part in this chapter where we're going to discuss this process. It's called esterification. From the processes that you must know, but for now, we're not there yet. For now, you must just be able to give the name of this thing. Okay, so we did one here on the right hand side where we have the parent chain only has one carbon and the side chain has two carbons. Side chain with two carbons, 2 is eth, and the side chain suffix is il, so it's ethyl, and then one carbon is meth. And because it is the parent chain, it's anoate, methanoate. The ester is the only one where the parent chain can be shorter than the side chain. All the others, the parent chain must be the longest. Esters is the only one where the parent chain can be shorter than the side chain. Any questions there? Something that I must repeat? Nothing. Okay. Now I want to go to something that they say here. They speak about a functional isomer. Okay, so now I want to go to that. I hope you still have space. So functional isomer, I'm going to go there. Now in grade 10, we spoke about isotopes. Isotopes. For 2 sweeties, can someone tell me what in the world is an isotope? Three sweeties. Say again? No. It's too easy.
Can you tell us what isomer is?
No, because then you know what an isotope is. Alright, so an isotope was a compound that has this same number of protons, same atomic number, but different number of neutrons, and thus different mass. Yes? You don't know about that? Let me just quickly go to the grade 10 notes that we did. That was with the atomic structure. Isotopes here. These were your exact notes. The same element, different number of neutrons. So here we had hydrogen 1, hydrogen 2, hydrogen 3. Right, so it must ring a bell, it should ring a bell. This is something that we expect you to remember from grade 10. Luckily they don't ask it in grade 12 that often, but they can decide that you must know something like this. Okay, so an isotope, iso, means same, but different. Okay, so what's the same? It's all hydrogen, it's the same element, but what's different? The mass is different each time. Why? Because the number of neutrons is different each time. Okay, so iso means same, but different. So in grade 12, an isomer is, there it says isomer means something's the same, but something's different. Okay, now when we have a functional isomer, it means the molecular formula is the same, but the functional group is different. Okay, the definition for that is on the next page. We'll get to that. So isomer means the molecular formula is the same, but the functional group is different. What's the functional group? Carboxylic acid, ester, ketones, aldehyde, blah, 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 blah. Okay, so when we look at this molecular formula there, so we have C3H6, I think, O2. Then the first thing that we just drew there at the top was an ester. Okay. I'm going to draw this ester. Check that you agree that the number of carbons are the same. Okay, so can you see 3 carbons, 6 hydrogens, 2 oxygens? Okay, right. What is this one's name again? Methyl or methyl ethanoate. All right, and that one belongs, because you see that one belongs to the esters. So the functional group is the esters. Okay, but you can take that one, you can take it all apart, break up all the carbons, all the hydrogens, all the oxygens, and then you can draw this structure. Okay, for a sweetie, to which homologeous series does this compound belong to? What is the functional group of the carboxylic acids? Almost. Okay, so this here is the carboxyl group, functional group, and it belongs to the carboxylic acids. Okay, what I want you to see here is that if there's 3 carbons here, then there's 3 carbons there. There's 6 hydrogens here. There's 1, 2, 3, 4, 5, 6 hydrogens there. 2 oxygens, 2 oxygens. So it means the molecular formula is exactly the same for this one as for this one. Okay, but the functional group changed. Okay, so the entire function of this thing changed. This one smells nice. It's probably smelling like, no, it's a fruit, some type of fruit. And this one is a vinegar type of thing. It's an acid. It will burn your tongue. Okay, so it's 2 completely different functions, but it consists of the same number of molecules. For a sweetie, what is this one's name? Yeah. How many carbons are there? Yes? No. Propanoic acid. Propan because it is 3 carbons. Propan because it's 3 carbons. And then propanoic acid. That is the suffix for a carboxylic acid. Propanoic acid. Okay. When we look at the So that is the introduction to isomers. So if we turn around to the next page, there's 3 different isomers that you must know, types of isomers. Okay. The first thing there is just a general definition for an isomer. What is that? So organic molecule with the same molecular formula, so same number of carbons, hydrogens, oxygens, whatever, but different structural formula. How we put them together is different. Okay, so we get 3 different types of isomers. We get chain isomers, positional isomers, and functional isomers. Chain, positional, functional. Okay, right. So a chain isomer is where you have the same molecular formula. You must an isomer means same molecular formula, but different types of chains. And with different types of chains, what we mean there is different length of parent chain. So different types of chains, what we mean there is different lengths of parent chains. All right, so let's quickly look at an example. Here we have butane. But means 4. 1, 2, 3, 4. Okay, and because you see the ane part, there's only single bonds, so the rest are all hydrogens. Remember, in the test and exam, you must fill in all of your hydrogens. If one is missing, then you don't get a mark, or you lose a mark, actually. Okay, now I want to write down the molecular formula. Molecular formula will be C4H10. For a sweetie, what do we call this thing here? Where you show each and every single bond? Yes? Structural formula. Structural formula. Okay, so this is the molecular formula. This is the structural formula. Okay, right. Now we must draw the isomer. Okay, isomer means it must also have 4 carbons, 10 hydrogens. But the length of the parent chain must change, or the length of the chain must change. Can I go draw it like this now? No, it's the same molecule, so we didn't change anything. Can I draw it like this? No, it will be butane. The name must change. It must be a different parent chain, so it can't be but. But it must have 4 carbons. How can we not have but it can have 4 carbons? No. In what way can I take these things apart, put them back together, but not have 4 carbons on the parent chain? There's your clue.
Can you use CH somewhere? Can you combine CH together?
No, you must, no. My clue is on the parent chain. Yes? Put a side chain on there. Yeah. Oh, it's Christmas today. Okay, right. So it means you can still have 4 carbons on your chain, just not 4 on your parent chain. So we can have 1, 2, 3. So 3 carbons on our parent chain. And then the 4th carbon will be on a side chain. Then I have 4 carbons. The molecular formula is the same. Now let's just count the hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they will be considered chain isomers. Why? Because the parent chain's length changes. We still have 4 carbons, 10 hydrogens for each one, but the length of the parent chain changes. Can I take that carbon and put it on one of the sides? No, because then it just makes an L, then it will be butane again. Okay, right. What will the name of this structure be for a sweetie? No, not an all. There's no alcohol there. No. No. Think, guys. Don't just guess. There's a side chain. So you must have a side chain first. Where does the side chain sit? Lepelo? Where does the methyl sit? Wish. Yes? Okay, right. So that will be 2-methyl propane. These questions that are asked for sweeties is now obviously just to reward you to get you going. But all these questions are questions that they can ask. So it's not just for the clever ones to give this name. You must be able to give this name. Everyone. Okay, right. The next type of isomer that we have is a positional isomer. So again, isomer means the same molecular formula, but now the position of something changes. The position of the side chain or the substituent, so the chloro or the bromo or the whatever, or the functional group changes. So the position in your head, the position of the weird thing changes. Okay. The example that we have there is 1-chloropropane. Pro means 3. 1, 2, 3. 1-chloropropane, 3 carbons, and then on the first one there's a chlorochichi. Where do you want the first one to be? Left or right? Okay, so Tapelo, what will the molecular formula be of that compound? Say again? C3. Say again? First your H's. H7Cl. Okay, so your isomer must also have 3 carbons, also have 7 hydrogens, and 1 chloro. Okay, right. Now it's not a chain isomer. It's a positional isomer. So the length of your parent chain stays exactly the same. You don't change the propane part. The propane stays the same. It's the weird thingy that changes. Where can it change to, Cananello? Yeah, where can it change to? Can I go put it there? No, because it will still be 1 chloro. Where do I put it? On? Yeah, where? If I put it here, then we will start counting from that side, then it will be 1 chloropropane. Say again? The second one. There's only one option here. Sometimes there will be more than one option. For this one, there's only one option. It must go to the second one. Vanele, what will the name of this compound be then? 2-chloro? Why? No. You're on the right track with propan. Do you see a ol? Do you see a OH? 2-chloropropane. All right. So then the last one that we have is a functional isomer. A functional isomer. Okay, now we have done one functional isomer where we go from an ester to a carboxylic acid. That's what we did on the previous page. But you can also go from a carboxylic acid to an ester. Okay, so this one here, methyl methanoate, is your clue that this is an ester. So you can go from an ester to a carboxylic acid. I'm just abbreviating there. All right, so just to show you, you can go from an ester to a carboxylic acid or from a carboxylic acid to an ester. They're both functional isomers. Okay, so the one that we have there, oh sorry, we didn't highlight, same molecular formula, but different functional groups. So you must change the whole functional group of it. Okay, methyl methanoate, you always start with methanoate, okay? But when you get an ester, I want you to always start with the functional group of it. So it's C double bond O, O, C. That must be there. No choice about it. Then you can add more carbons, but this must be there. Okay, so let's just check. Methanoate means one carbon. On the parent chain, there's one carbon. So let's check, that's fine. Then methyl means one carbon. There's the one carbon. So in this instance, you don't actually add more. We're just going to add in our hydrogens. Lapilla, what will the molecular formula be for this one? C2. First the H's. Yes. O2. Tiamo, I'm just going to ask you, are you allowed to draw it like this for me in the exam? What's wrong? I think you all know. It's just someone that was sleeping. Tiamo, there's a reason why I'm asking this. Because I know you are the one person that will do it, and then you'll fight with me because you'll say, ma'am, in class you do it this way. Can I later tell them? You must add your hydrogens.
Man, I remember, I thought I knew that you were asking something very difficult.
No, for you it's always easy. I'm just kidding. So please fill in your hydrogens. Okay, right. So we must draw. So I'm going to say this again. If they ask for a functional isomer and they give you an acid, you immediately know you must draw carboxylic acid. Okay, so you must draw carboxylic acid now with the same number of carbons, hydrogens, and oxygens. Ek nou by jou wees. Mouse, what do we call this thing again? This? What formula? Molecular formula. So please draw a carboxylic acid with the same molecular formula. Go.
The same.
Same molecular formula, but it must be carboxylic acid. Start with the functional group. Always. If you think you got it right, put up your hand so I can reward you. Alright, so you start with your carboxylic acid's functional group, the carboxyl functional group. Then you see, alright, I must have 2 carbons. There's 1, so I just add another one. Alright, let's just check. 2 carbons, 2 carbons. 4 hydrogens, 4 hydrogens, 2 oxygens, 2 oxygens. Okay. Remember, for the esters, carboxylic acids doesn't matter. It can be the mirror image as well. So the functional group can be on this side as well. Or these 2 things can be swapped around. Chop. The name for that compound Unati will be what? How many carbons? 2. What is 2? Okay, so you say ethan. And then what's the suffix for a carboxylic acid? No, not O8. That's an ester. Noic acid. Ethanoic acid. And that's the same as vinegar. Alright. Now you get 2 functional isomers. The one is an ester and a carboxylic acid, and the other one is between for a sweetie, what is the homology series to which the anal group? Aldehydes. Oh, sorry, I'll give it. Okay, so this is an aldehyde. So this can be a functional isomer with what? For two sweeties. What do you think can be the functional isomer of an aldehyde? No, carbonyl is a... No, that's the functional group of an aldehyde. I'm asking which homology series can I write down here? Alkanes, alcohols, carboxylic acids. Yes?
I'm just taking a guess.
Okay.
Alcohol.
No.
Alkanes.
The ketones. Why? Because they look exactly the same. We're going to look at it now. So the ketones. Okay, let's quickly look at what this will look like. Propanol, Tiamo. Propan, how many carbons? 3. 1, 2, 3. Propanol, anal belongs to the aldehydes. The aldehydes means it must be at the end. At the end must be what? A carbonyl functional group. Your double bond O. So the molecular formula will be C3H6O. Right? Now we must draw a ketone with the same molecular formula, so exactly the same number of carbons, hydrogens, oxygens, but now it must be a ketone. Chichi, what will that look like?
C. C again. Double bond O. C. C6 and then hydrogens on the first and the last.
Alright, good. So if we check there, you can see 3 carbons, 3 carbons. 6 hydrogens, 6 hydrogens. 1 oxygen, 1 oxygen. So this can easily be confused with a positional isomer. Because it looks like the position just changed, but it didn't. This is an aldehyde, this is a ketone. They can ask a ketone as a positional isomer, but then it will be a longer chain. Then it will say be octan 2-one and then octan 3-one. Okay, then it's a position because the octan didn't change. Okay, the own didn't change. Alright, so this is the ketone one because the double bond O is in the middle. And what will the name of that compound be, Tapelo? Propan. And then? Okay, so this one is one of those things where there's actually only one right answer. It's actually propanone because it cannot be propan 1-one, then it's an aldehyde. It cannot be propan 3-one, it's an aldehyde. So it must be propan 2-one. So there's only one answer. But you could have said propanone or propan 2-one. Alright, so they are all called functional isomers. Functional isomers. So that's, I just asked that for my subject advisor, until where. So I'm just waiting for a reply. So while I wait for his reply, let's do on page, this one, page 27. This is a past paper question. Okay, so this is, you'll always get something like this. After the multiple choice question in chemistry, you get a question like this where they give you a few structures and then you must answer questions regarding them. Short answers, 1 mark, 2 mark, maybe a definition here. Alright, so there they give you a few. What you do first when you get them, you look, you write their molecular formula for each one and you say to which homologous series it belongs to. Okay, so let's look at A, Cananelo. What will be the molecular formula for that structure?
What do you start? The
Eight. All right. To which homologous series does it belong to, Banele? No, man. No, not the name. Just yeah.
Just double bond. Alkenes.
It belongs to the alkenes.
Ask me why, man.
Say again?
Ask me why.
Why? Okay, so no, we must do one more part. Okay, right, the next one, the molecular formula. C, H, Eight. Okay, and to which homologous series does it belong to? Mouse? Alkenes. So as you write this down, immediately say, but wait a minute, their molecular formula is the same. So it means there must be isomers. There must be. Okay? But something is different. What isomer? Chain, positional, functional. It's not a functional because it's alkenes, alkenes. Can you see that the double bond is on the first one, the double bond is on the first one? So it's not a positional. So it must be a chain isomer because here you have 4 carbons on the parent chain, here you have 3 carbons on the parent chain. So immediately you pick up something and you know there'll be a question on it, so you can already answer that question actually. Okay? If we look at the next one, butene and Tiamo, to which homologous series does it belong to? Enes. Huh? Okay, sorry, I'm getting nervous because the bell's going to ring. So it belongs to the alkenes. Okay, the alkenes. Then I want to write the molecular formula, but I can't go count it. I can go draw it. Okay, so you can quickly draw it for yourself. 1, 2, 3, 4, and on the second one there's a double bond. Or you could have said, all right, this belongs to the enes. The enes general formula, CnH2n. So if I must write down its molecular formula, then there will be 4 carbons, because but is 4. And then there must be 8 hydrogens. Then you say, my goodness, this is the third one that's like that. So they are all isomers of one another. Okay? Can you see these two are the closest together? 4, 4. And the parent chain. What changed? The position of the double bond. So it's a positional isomer of one another. Alright. Then the next one there, the molecular formula will be C4H8O2. And to which homologous series does it belong to, if you see that? There's only 2 that has 2 oxygens in it. It's either the carboxylic acids or the esters. Carboxylic acid, do you see the H at the end? This whole thing is at the end. So this is a carboxylic acid. Alright. Next one, you see there, methyl propanoate. O8 is esters. Okay. Methyl propanoate. Meth is 1, pro is 3. So how many carbons? 4 carbons. C4. Okay. Then you can quickly go draw it for yourself. I'm just going to be quick. It will be H8O2. It will be that if you draw it. So you can see there, okay, wait a minute. These two have the same molecular formula, so they're isomers, but the functional group changed. Okay, so they are functional isomers of one another. Right, next one there, you see C4H8O, I think. You see the toe sticking out there somewhere in the middle. So this is a ketone. And this one will be C5H10. And you see the double bond there, so it will be an alkene. Okay, right, now the ask. Write down the letter that represents a chain isomer of compound A. Okay, so we already said, wait, compound A there, the isomers for A can either be B or C. Chain isomer means the parent chain's length must be different. This is butane, this is butane, so it can't be that one. This is butane, this is propane, so they are chain isomers, so then it will be B. Then they ask for a positional isomer of compound A. A positional isomer of compound A. We saw it will be C because the position of something changed. Then they ask for a functional isomer of compound D. And we already said that is E. Can you see how easy it is if you first look at all the things? Good. Then write down the IUPAC name for compound B. The name for compound B. Okay, let's go to compound B. There it is. You go to your parent chain. There's your parent chain. And then you see you have your side chain. Will you start counting from the left-hand side or the right-hand side? Left. 1, 2, 3. You start counting from the left because it's closest to the first functional group or side chain or whatever. Okay. The parent chain has 3 carbons, so it will be prop. Okay, and then you see there's a double bond on the first carbon. So are you going to write prop 1-ene? No, because if the double bond was here, then you'll start counting on that side. Then it will be again 1. Okay, so it's propene. You can write prop 1-ene, but it's not necessary. And then you see you have your side chain. On the second carbon, you have a side chain. So on the second carbon, I have what? How many carbons are there? 1, so it's methyl. Okay, so you put them together. I'm just going to go to my question. So that will be 2-methyl propene. Alright, then they ask, write down the molecular formula for compound C. We already did that. There is my molecular formula for compound C. Alright, then write down the structural formula for compound E. I'm going to draw this here at the bottom. So this is question 4. The structural formula for compound E. Okay, I'm just going to rewrite the name. E was methyl propanoate. Propanoate, no, 8 tells me I'm working with the esters. So I'll immediately start with the esters functional group, which is carbon, double bond O, O, carbon. That must be there. Okay. Can you see how you must know what is an ester? What is a carboxylic acid? Those names. That's why I gave you a speed test. Alright. Methyl means 1 carbon. There's my side chain. There's 1 carbon. Check. Propanoate. Pro means 3. There's only 1 there, so I must add 2 more. And then you fill in your hydrogens. Okay, next one. Write down the structural formula for the functional group of compound C. So not the whole thing, just the functional group. Okay? So for compound C, there's C. The functional group is that ene part. Okay? So the ene part, so I'm going to do question 5 here. The ene part is just the carbon, double bond, carbon. Okay? And then it can make 2 more bonds. But you don't have to put in the hydrogens. Okay? Because you can have another carbon going on there and another one there and another one there. You can go on like that. So those lines just means something can be attached to it, but the functional group is this thing. Okay. The compound C, I think, was butene. Okay. If you drew butene, then you don't get your marks. They don't want you to see it's butene. They want you to see that it's not butene, that it's just an ene part. So they only want to see this. I know this looks like ethene, but they only want to see the double bond. Are you guys still off now? Okay, I do have a class, but let's finish this, and then maybe you can sit at the back, and I can give you more things to practice. Unless you have homework. Or you want to go back to the hall? Okay. It is a massive class that I do have now. And you know what? I'm going to send you maybe to Mr. Milan's class. Because the class that I have now is almost 40. Alright. Then question 6, they ask, write down the IUPAC name of the compound that contains a carboxyl group. So carboxyl group we find with the carboxylic acids. So there I need to find a carboxylic acid. There's my carboxylic acid. Now I need to give the name. So can you see it becomes more difficult, the questions. Okay, so you had to know carboxyl group you find with the carboxylic acid. Which one is the carboxylic acid? This one. What is its name? Well, it has 4 carbons. 4 is but. And what's the suffix for carboxylic acid? Anoic acid. So 6 will be butanoic acid. Okay, question 7. Is compound A saturated or unsaturated? Give a reason for your answer. Yes? Yeah? A. Unsaturated. So you will have got your sweet. So it's unsaturated. Yeah. Then it's unsaturated. Unsaturated. And they ask why? Can you just say there's a double bond? No. There's a double bond between carbons. Because here, you also have a double bond. But this compound is saturated. Okay, so you must say the double bond between carbons. Unsaturated double bond between carbon atoms. Alright, and question 8. Write down the name of the homologous series to which compound B belongs. B belongs to the alkenes. Alright, just to prepare you mentally, because I do see you tomorrow, the last period. Okay, and then you write the next day. You still, or we still, have to discuss page 15. Okay, so if you want to take this time and go through page 15, page 15 has to do with, this is a grade 11 chapter where we look at the intermolecular forces, thus more energy is needed to overcome the intermolecular forces between the particles. That whole thing, you have to write on that as well. So this page is just a summary of it. There's a different things that we can change. And then here's your answers on how you can answer it. Okay. Are you guys going to sit in Mr. Milan's class? Can I send someone to copy past question papers for you guys so that you can go through question papers for chemistry? Siamo will take forever to get there. All right.